Hi, and welcome to the first devlog of Orbis Multiplex, a complex simulation-oriented 4X indie strategy game on planetary scale. In this game, the player will lead a nation from late Stone Age all the way into the modern era, all whilst adapting to an ever-changing environment. In this first video, I'll briefly describe and highlight the core concepts of the game, and at the end of the video showcase the current state of the game. Before continuing, I'd like to make it clear that the game is still in an early development stage, and many of the core game mechanics are not as of yet implemented. That being said, let's begin. The foundation of the game lies in the simulation of certain systems. Some of those systems would be geology, hydrology, climatology, ecology, and economics. A true-to-life and realistic world with dynamic features will be vital to this game. Things like plate tectonics and erosion will be used to create realistic planets. Climatology and ecology simulations will be used to inhabit a world with realistic animal and plant distributions. In terms of gameplay, a three-component system will be used to model the economy, the player having control over only one of these components. I will talk more in depth about the economy later in the video. Interactions amongst these different simulated systems will play a key part in gameplay. The player may, for example, make certain animals extinct by overhunting, thus destroying a long-term food source, or prevent desertification by preserving woodlands in key areas. Another interaction could be pollution from industries killing fish downstream. In too many games, the world is a static map onto which the player builds and conquers. Not so here. The world will be alive and change over time as the player develops his society and adapts to the environment. One of the core philosophies of the game is the idea of macro over micro decisions. With this, I mean that the player will mostly make decisions on a high overreaching macro level. For example, setting tax rates, researching technologies, making trade deals are all macro scale decisions. Examples of micro decisions would be moving individual soldiers, constructing individual buildings, controlling individual people. Micro-scale decisions can be tedious and repetitive, and on a game of this scale they would be both annoying and boring. However, making large-scale decisions and observing how they influence lower-scale areas will be interesting. For example, increasing the tax rate on coal could in the long run lead to deforestation, as the population seeks cheaper alternatives for heating. Unforeseen consequences of these decisions will be both inevitable and fascinating. I will now briefly outline the planned economy system. The economy will consist of three parts: the population, the private sector, and the ruler. The player will take the part of the ruler. The population and the private sector will be 100% AI controlled. The player will be able to interact with these systems, but only indirectly. This image shows the flow of wealth and resources in the economy. The population need to consume resources to survive and thrive. These they buy from the private sector. To gain wealth, they work for the private sector. Excess wealth in the private sector can be used to develop new industries, thus growing the economy. This interaction between the private sector and the population will function without any player input. The player may, however, collect taxes, thus indirectly influencing the other parts. With the collected tax, the player may choose to spend the wealth on different government projects, like infrastructure and scientific development. Tax rates will be one of the ways the player interacts with the economy. Set too high taxes, and the private sector and population may suffer and stagnate. set too low taxes and you won't be able to run the country. This balance between taxation and economic growth will be an interesting part to examine. The production chains present in the late Stone Age might look something like this. Products such as food and clothing will need to be consumed by the population, whilst the ruler might need building materials and weapons in order to further his goals. As the ages progress and new technologies are discovered, new products will be added, whilst others might become obsolete. I will now showcase the game in its current stage. At the moment, no game mechanics has been implemented. It is merely a procedural planet generator at this point. The world consists of roughly 1 million triangles, each covering roughly 400 square kilometers. Each triangle has values like bedrock depth, sediment depth, water content, and water flow. This planet has been created by initializing elevation by the help of multi-layered polar noise. After the initial elevation creation, a fluvial erosion algorithm is run. The erosion algorithm creates graph trees representing drainage basins. For these trees, water flow is calculated from leaf to root. Erosion is then calculated from root to leaf, based on the water flow. Higher water flow and higher slope leads to stronger erosion. The blue lines here visualizes rivers. Some rivers are short, whilst others span entire continents. Apart from rivers, drainage basins may be visualized. Here, each tile has a color representing a specific tree graph. The water of each tile that shares color eventually drains into the same river or water body. Other visualization filters have been implemented like water flow or tectonic uplift. The tectonic uplift map is used during the initial simulation. It can be seen that mountain ranges tend to form in areas of high tectonic uplift. The formation of dynamic lakes are also present in the simulation. These lakes might be closed, like the Caspian Sea, or they might be open lakes, like the Great Lakes of North America. At the moment, I'm busy improving the erosion simulation. No real continents are this hilly and mountainous. Features which are not present here are floodplains and steppes. Important parts of a realistic world. Sediment transportation is one key part in these features and will need further improvement. With that, I'd like to end this first devlog video. I plan on making new devlog videos at least twice a month, highlighting added features and mechanic changes. If you'd like to follow the project and download the game in its current stage for free, visit the project page on itch.io. Thanks for watching.